let's go over the solutions for the flame detector lab. The system requirements is the lowest package cost, so it's not in terms of money but in terms of the amount of packages that we're going to use, and I do not have NOT gates available. So let's go and see how are we going to develop the solution for this. So we have this toxic waste incinerator. They want to monitor the flame. They put 3 sensors over here, and it's just for a matter of redundancy that they have 3 sensors. And question number A is asking for you to design the minimum cost that implements the fixture described above, and which is have at least 2 sensors giving a good information. You don't sound the alarm. So let's go over the solution here. I have a piece of paper and we have 3 sensors, so I'm going to call that sensor A, B, and C. So let's put here our combinations, our truth table. All right, and the first one is going to be my alarm system, and my alarm system is going to be 1 if I have 2 sensors that are not good. So here alarm is 0, only 1 sensor is bad, everything is fine. Here 2 sensors are bad, I put a 1, here I get a 0, 1, 1, and 1. This is my truth table. So now let's design our K-map. So to design our K-map, do not forget to tell that you have A, B, and C over here. So I get 0, 0, 0, 1, 1, 1, 1, 0. This is 0, this is 1. Perfect, let's put the zeros and the ones. So I get 1, 0, 0, 0, I get a 0, 0, and a 0 and a 1. And on this one I get 0, 1, 1, 1. Perfect. Alright, let's use red for my SOP. Sum of products, I'm going to group the ones. So if I group my ones, I have 1 over here, 1 over here, and another 1 over here. So my F is going to be equal to, so the first grouping is this one over here is going to be have in common your B and C. Now this group over here is going to have in common the A and the C, and at last this one is going to have A and B. Alright, cool. Now let's go over our pause, because we might have, let's actually use blue for that. We have a better answer. So for my pause, product of sums, I'm grouping the zeros, so I have these two together, and I can just take right away as my F. So if I know that I have for this one, if I was doing the SOP will be A negated and C negated, so I know that here I have the opposite, so I have AC. Perfect. Now I go and I group these two. These two would have been A negated, B negated, so in my case I put A or B. And at last I have this 0 that can go with this 0 over here, which is should have been B negated with C negated. So let's put B or C. And let's bring our SOP. So we have our SOP and our pause. Which one is the easiest to implement in this case? Well, let's go and build the circuit here for this guy really quick. So what I have is 3 AND gates connected with an OR gate, and this is what I have. And for my pause, if I build this circuit, I have 3 OR gates connected to my AND gate. So it has exactly the same cost. As you can see here, we have here, I'm going to use two ICs, and I'm also using 2 ICs over here. So if you recall the package, we have available here AND gates with 2 inputs or 3 inputs, and the same thing with the ORs. So it doesn't matter what we do, we have exactly the same cost. So I'm going to use the SOP, just random selection here. Perfect. We have our alarm, and now our exercise also asks on B to find the sensor disagreement. So it's pretty much saying, like, when the sensors do not agree, all of them, I want to raise an alarm. All right, so let's pull our spreadsheet here and let's create a new one. So let's get rid of all these, and now I have a new truth table, A, B, and C. So this is for B, and this is my sensor disagreement. Actually, let me do something really quick here. I'll duplicate these and activate, because it's already here. All I need to do is just erase these because it's different, and also the zeros and the ones. All right, and now let's design the sensor disagreement. So it's 1 in all of them, besides when all the sensors are in agreement, which is these 2 states. So if I put the information here, I get something like this. And let's find our SOP. All right, our SOP is going to be by grouping all the ones together. So I get these 2 ones together, these 2 ones, and these one. Notice that I can have different groupings. If you have different groupings, it's also working. And my F is going to be equal to, for this first one over here, I get A negated and C. For the top one over here, I get B and C naught. And for this one, I get A and B naught. Let's just design the circuit really quick. So I get, again, 3 AND gates with my OR gate. But now I have a couple of negations on these. Okay. Now let's go over our pause. And these are the ones that are here, the zeros that are here by themselves. And let's take that equation. So the first one is going to be A or B or C. So this is this one over here. And for this one, we'll get A naught or B naught or C naught. Let's build this guy. We have an OR gate, and AND gate. This one has all the inputs negated. Let's bring our SOP and see which one is the easiest to implement. Oh, sorry about that. And remember, I don't have NOT gates available. So all these ones that you see over here, I need to make negations out of them with either an AND or an OR, for example. So if I implement these with all NANDs, do I have NANDs available? Let's see. I have NANDs with 3 inputs. Good. So probably I can go here and I can implement all this part with NANDs, and I get 1, 2, 3, 4, 5, 6, 7 NANDs. Let's go over the package here. The NANDs for 3 inputs have 3. For 7, I need 3 ICs. Okay. let's keep analyzing. So if I do all NANDs over here, I get 3 ICs. Right now I have 1, 2, 3. I have, if I just use normal AND and OR gates, I use 1, 2, 3. I use one IC for the ANDs, 1 IC for the OR 2, and then I need to do these NOTs, so I'm using also 3 ICs. And if I go here on the pause, I'm using one AND and an OR and these guys. So I know that by De Morgan's this is equal to an AND, which probably doesn't get me anywhere. So let's see if I can, if I substitute these by an AND, and then let's see if I can do all NORs on this guy. So in order for that to happen, I need to negate these twice so I don't change the integrity. And this one is going to use 2 ICs. It's going to use 2 NORs over here, and then just the AND with 2 inputs. So pause with this technique here is the best. So let me actually make this a little bit better so you can see what I'm doing over here. So let's remove the SUP. I don't need the SUP. And let's improve the circuit. So I know by De Morgan's that OR gate with the inputs negated becomes an AND, and then this guy I can negate here as long as I negate that same wire twice. I don't change the integrity of my wire. So this is an OR, and in order for this guy to be an OR, I need to negate again twice. So I'm going to negate like this. All right, perfect. So now I know that I have an OR, and these 2 NOTs can cancel each out, and I have an AND. So I get 2 ICs out of my sensor disagreement. So I get 2 NORs and 1 AND. Perfect. Let's go back to our initial design over here, the one that had the alarm, and the alarm I can do, oh actually I can do this one, yeah, 2 ICs. I can do this one with 2 ICs, either all NANDs or not. So let's pick up, let's do it all NANDs just to practice. So let's remove these and let's design all NANDs. So I get NAND, NAND, and NAND, and my NAND. Perfect. So if I go on my package, the NANDs, I have NANDs with 3 inputs, so I'll be using one of these and one of these. So 2 ICs over here. 2 ICs with just NANDs. So 3 input and 2 input NANDs. Alright, cool. Oh, sorry. I'm just writing these 2 ICs. Perfect. So let's implement these 2 options. So this is my first solution over here, and my second solution for question number B. All right, cool. Let's open Logisim. Oh, I don't have it over here. All right, Logisim, and let's make it smaller, and let's make also these ones smaller, and let's bring these 2 and build this. All right, so I have NANDs. Let's go over the gates. NAND, and 3 input NAND and 2 inputs here. Oh, sorry, just change that one. Another NAND, 2 inputs. Alright, my output is going to be alarm and A, B, and C. So sensor A, sensor B, and sensor C. And the first one is B and C. Let me just align these. The first one is B and C. The second one is A and C. So let's design A and C. And the third one is A and B. Here you go. All right, let's see if it works. Let's test it. So alarms at 0, everything is fine. If I have 1, no alarm, 1, no alarm, 1, no alarm. If I have 2, my alarm goes on, 2, alarm goes on, 2, alarm goes on, 3, alarm goes on. Perfect. So this first one is done. This is my alarm circuit. Let's just put bold 18 so we can see it well. Perfect. And now let's go over our sensor disagreement. So this is the sensor disagreement, which shares the same inputs A, B, and C. But now we're going to use these NORs. So let's go over here and pick up a NOR with 3 inputs. And then another NOR with 2 inputs. And we have also AND gate with 3 inputs. Alright. Let's put our output. This is our sensor disagreement. Sensor disagreement. And now on that first one we get ABC. So let's pick up the A, B, and C. And on the other one we have A, B, and C. So I can put this a little bit closer. Perfect. Alright, let's see if it works. Let's just copy this one and say that this is our sensor disagreement. Sensor dis. Let's test it. And right now all the sensors are agreeing. If I press 1, they disagree. If I press 2, they disagree. And if I 3, they are all in agreement. And here you go. This is your system working with less gates. So notice here that it covers pretty much all the options that we have. If I have the sensors all working fine, none of the sensors, all the sensors are working fine, all of them agree, everything is good. It's the 0-0 kind of condition. So I can go here if let's just put it here. So I have 4 options. If the alarm is 0 and the sensor disagreement is 0, this is when everything is working properly. But if I have alarm 1 and the sensor disagreement, and I have the sensor disagreement, so let's put it like this. So alarm is 1 and the sensor disagreement is 0. That means that all sensors are bad. And the other condition is if my alarm is 0 but the sensor disagreement is 1. Let's see if we can do this one. Here you go, this situation. Then I have at least one sensor bad. And then the last condition is if both of them are on, 1 1. So that means that this condition here, I have 2 sensors bad. So actually this one is not at least, it's I have 1 sensor bad and 2 sensors. Here you go. And this is covering all your possible solutions here. So either everything is working properly, or all sensors are bad, or 1 sensor is bad, or 2 sensors are bad.